Welcome all. Today we are going to discuss about the mesh analysis. So using mesh analysis, we are going to find out the current through 10 ohm resistance. So this is the circuit. So in this circuit, we are going to what current flowing through this 10 ohm resistor. For mesh is nothing but we can also call it as loop method. Here we are going to find out the loop current. For that, you have to assign or you have to identify how many loops in the circuit. So I am going to consider A, B, C, D. This is one loop. Again, here I am going to consider B, E, F, G. This is one loop. So totally 2 loops in the circuit. So step 1, for mesh, we are going to identify how many loops in the circuit. So totally 2 loops. So step 1 is identify how many loops in the circuit. So here 2 loops. So 2 loops. So step 2, you have to mention or label the loop current. So you have to label loop current. This loop I am going to label as I1 and this loop I am going to consider I2. Then step 3, assign the direction of the loop current. So this loop current you are going to assign which direction is going to flow. This is your assigned direction only. You can go with clockwise or anti-clockwise direction. So I am going to assign here as clockwise direction. So here also I am going to assign with clockwise direction. So in this circuit, they are giving source voltage as 20 voltage for this loop. Here it mentioned 60 voltage. Step 4. So for mesh analysis, we have to use KVL method for finding the loop current. Apply KVL for both the loop. So step 4, apply KVL. I am going to find out the loop current for this loop A, B, C, D. Apply KVL at loop 1, A, B, C, D. So all of you know what is KVL is nothing but Kirchhoff's voltage law. So Kirchhoff's voltage law defines that the sum of the applied voltage plus sum of the product of the voltage and current is equal to 0. So sum of the applied voltage plus summation of voltage into current into resistance equal to 0. So I am going to apply KVL for this loop 1. So here 20 voltage. For KVL method, we have to check the direction of the actual current flow as well as your assigned direction. this arrow, this is your assigned direction current flow, this arrow head ends at positive. So minus to positive, its end at positive means you have to take plus 20 voltage. Then actually for branch current, you have to take plus minus means this is the voltage drop. This IR is nothing but voltage drop or rise at this element. Here they given 20 ohms resistor. So the current flowing through this 20 ohm resistor is I1 and then this R is 20 ohm. So minus plus into minus, it ends at minus. So minus 20 resistor value 20. The current flow through this resistor is I1, 20 I1. Then one more resistor also flowing through this loop 1. Here the 10 ohm resistor is a dependent resistor because this 10 ohms resistor is common for both loop I1 and I2. So for that you have to mention 10. So if you are considering loop 1 means you have to write 10 I1 minus I2. If you are assigning for this loop means it should be like 10 I2 minus I1. So I am writing the equation for loop 1. For that 10 minus 10 I1 minus I2. I1 loop current 1 minus I2 is equal to 0. So I am going to simplify this equation. So 20 voltage minus 20 I1 minus 10 into I1 minus 10 I1 minus minus plus 10 I2 equal to 0. This 20 minus 10, it will become 30. So 20 minus 30 I1, then plus 10 I2 equal to 0. I am going to take this I1, I2 to the left hand side. So 20 equal to minus 30 I1 which goes that side means it will become positive 30 I1 minus 10 I2 equal to minus 10 I2. So this thing will divided by 5 for simplification. So it will become 2 equal to 3 I1 minus I2. So I am going to consider this equation as first equation. 3 I1 minus I2 equal to 2. This is equation 1. Same thing, I am going to apply KVL at loop 2 B, E, F, G. So step 5, apply KVL at loop 2 is nothing but B, E, F, G. B, E, F, G. So I am going to consider this loop now. So here applied voltage minus, that is nothing but IR equal to 0. So here you have to check whether there is any source voltage which is given or not. Here they mention 60 voltage as your source. So once you write the source voltage, you have to check with the assigned direction with your actual terminal in the source. So here the arrow head ends at minus, negative. So you have to write minus 60 voltage is nothing but your supplied voltage minus IR. So this is your branch resistance. So minus 60 minus 60. So we are going to write for this loop. So I2 minus 60 I2. Then this 10 ohms resistor also present in the I2. So you have to write minus 10 minus 10. This is the, again, this is the dependent resistor. So you have to write I2 minus I1 equal to 0. So I am going to simplify this equation. So minus 60 I2 minus 10 into I2 minus minus plus. So plus 10 I1 equal to 0. Here, so 60 I2, 10 I2 minus minus. So it will become plus. So minus 60 minus 70 I2 plus 10 I1 equal to 0. Then this 60, 70, 10, it also divisible by 10. So you can write minus 6 minus 7 I2 plus 1 I1 equal to 0. So I am going to take this equation to that side. It will become minus 6 equal to minus plus I1, it will become minus I1. This minus 7 I2 will go that side, means it will become plus 7 I2. 7 I2 equal to 0. Sorry, not equal to 0. We are just take that side. So this is your equation 2. So we got two equation. From this system of equation, we are going to find out the unknown parameters I1 and I2. So your equation 1 is minus 3I1 minus I2 equal to 2. This is your first equation. Then here minus I1 plus 7 I2 equal to minus 6. So this is your second equation. So if you are solving this equation, you can solve this equation using your calci also. Using calci, you have to go more clear. Then if you are pressing 3 times, means it will show equation matrix VCT. I am going with equation method only. So you have to press 1. It will ask how many unknowns. So here I1, I2. You are having 2 unknowns. So you have to press 2. It will ask what is your A1 value, B1 value, C1 value. So you have to press your parameters, coefficient of I1 and I2. So A1 is coefficient of I1. It is nothing but 3. If you press equal, means it will ask B1 value. It is minus 1. If you are pressing equal to, means it will ask. So your equal to value is 2. C1 is 2. Then again if you are giving equal, means it will ask I1 coefficient, A2 coefficient. It is minus 1. Then B2 is plus 7. C2 is minus 6. So your I1 value is 0.4. I2, if you are pressing again equal, means it will show your I2 value also. So here I2 as minus 0.8. So this is the current value of I1 and I2. This is, so you have to mention the unit of current as amps. So I1 loop current 1 is I1 equal to 0.4 amps, I2 equal to minus 0.8 amps. So they asked what is the current flow through 10 ohm resistor. In this circuit, 10 ohm resistor is here. This is your 10 ohm resistor. It is a dependent resistor. It is share with both the loops. So you have to write current flowing through 10 ohm resistor, which is equal to I1 minus I2, or you can go with I2 minus I1. The magnitude will be same, the direction will be differ. We no need to bother about the direction. If the magnitude is same, your answer is correct. So the current flowing through 10 ohm resistor is, I am going to take I1 minus I2. So your I1 is 0.4, I2 is minus 0.8 amps. So I10 ohms equal to minus 0.4 amps. So actually here minus 0.8. So minus I1 minus I2. So it will become plus, right? Because I1 is 0.4, minus of I2 is minus 0.8. So minus minus it will become plus. So your answer is 1.2 amps. So the current flowing through 10 ohm resistor is 1.2 amps. So this is the one method for finding your I1 and I2. Same method, you can use another method also for cross checking the answer. So we will go with, we will see about the next method also. So another method also you can use, that is called as inspection method. So it is nothing but a matrix method. It is also known as matrix method. So now we can see about this method. So inspection method, we know that voltage which is equal to I into R, right? So you have to check how many loops in the circuit. Here we are having 2 loops. So your in inspection method, it has 2 cross 2 matrix. So you have to write in 2 cross 2 matrix R11, R12, R21, R22. This is your resistance. I, we don't know, we have to find out I1, I2. Then V. V in question itself, they will mention V1, V2. So for using inspection method, you have to keep in your mind the off diagonal element should be positive, other diagonal element should be negative. So you have to mention R1 to R21 should be represented in negative. Now you have to fill this matrix R11. It means that the total resistance present in loop 1. Loop 1 alone. So you have to check only this loop. Here 20 ohms is there, 10 ohms there. So you have to add it. So 20 plus 10 is your loop 1 total resistance. 20 plus 10. Then you have to check R12. R12 means loop 1 and loop 2 common resistance. So here it mentioned as 10. So you have to put minus 10 because in formula itself we mentioned minus, so you have to put that minus. Then R21. 21 is nothing but the resistance which is present both the loop. So here it has 10, right? This is second loop, this is first loop. So 10 ohm resistance minus 10. Then R22. 22 means total resistance present in the loop 2. So 60 plus 10, it will become 70. So 60 ohms plus here 10 ohms. Then you just write as it is I1, I2. We are going to find out this current only. Then V1, V2. So V1 is nothing but loop 1 voltage. So here the source voltage is 20 voltage. So you have to check with the assigned direction with your actual direction. So this arrow hence at positive. So you have to write 20 voltage, positive 20 voltage plus 20 voltage. For V2, it is nothing but the source voltage present at loop 2. If they didn't mention any voltage source in loop 2 means you have to put 0 there. But here in loop 2 they mention 60 voltage. Once again you have to check with the direction. So the arrow ends at negative. So minus, here this is positive, this is negative. This arrow, the loop current I2 flows through positive to negative. So you have to mention minus 60. So 20 plus 10, 30, minus 10, minus 10, here it becomes 70, I1, I2 equal to 20 minus 60. So using this matrix, you can form the equation and also you can use Cramer's rule also. So I am going to form the equation, then we will check with the Cramer's rule. So 20 I1 minus 10 I2 equal to 20. Then minus 10 I1 plus 70 I2 equal to minus 60. This is equation 1, this is equation 2. So I am going to divide by 10 because the all numbers will divide by 10. So it will become 3I1 minus 1I2 equal to 2. Then minus 1I1 plus 7I2 equal to minus 6. So this is your equation 1, equation 2. The same equation you will be getting the previous method also. So using your calci, once again you just check it. A1 is 3, B1 is minus 1, C1 is 2, then A1 is minus 1, B1 is B2 is 7, then C2 is minus 6. Your X value, it means that I1. Your I1 value is 0.4, I2 value is minus 0.8. So they asked the current flowing through this 10 ohms resistor. So I 10 ohms equal to I1 minus I2. So I1 is 0.4, your I2 is minus 0.8. So minus of minus 0.8, minus minus will become plus, 0.4 minus minus plus, so 1.08, it will become 1.2. So I 10 ohms, the current flowing through 10 ohm resistor is 1.2 amps. So you can go with any method. Suppose if you are applying KVL, if you are confused with positive and negative direction means you can use the inspection method and you can also cross check it whether you got the correct answer or not. The same problem you can use with Cramer's rule also. So using Cramer's rule. Using Cramer's rule, you no need to form the equation. From matrix, you have to find out the determinant of the matrix, and you can easily solve I1 and I2. So for that you need del 1, del 2. So del 1, del 2 is your unknown parameters I1 and I2. So for finding del, so already you form the matrix, you have to take this matrix alone for del. So it is 30. You can divide there also, divided by 10. It will become 3 minus 1 minus 1, here 7. So this is your del matrix. You have to find out the determinant of the matrix. So 7 into 3, 21, minus minus will become plus, plus into actual determinant. For finding determinant, there also one minus will be there. So plus into minus, minus, 1 into 1, 1. So you will be getting del as 20. Similarly, you have to find out del 1. For del 1, you have to replace this column, 3 minus 1. You have to replace with 20 and 60. So you already divided by 10 here, it will become 2 and minus 6. So here you have to represent 2 minus 6 here as it is. You no need to change this column. You have to replace the first column alone. So 2 minus 6, here minus 1, 7. Similarly, you have to find out the determinant. So 7 into 2, it will become 14. 6 into 1, minus minus will become plus. Plus into minus, it will become minus. Minus 6 equal to 14 minus 6, 8. Okay. So using Cramer's rule, your I1 is nothing but del 1 divided by del. So del 1 is 8, del is 20. So if you are dividing, eight divided by 20, it will become 0.4. So I1 is 0.4. If you are using KVL or inspection method or using Cramer's rule, the value are same. So 0.4 is your I1. Similarly, you have to find out your del 2 value. For del 2, you have to replace this matrix 2 minus 6 with this column. You have to replace this column. So here it is 3 minus 1, this column. Instead of 1070, you have to replace this 2060. It is divided by 10. So here 2 minus 6. So 3, 1 as it is. You have to replace only the second column. So 6 into 3, 18, minus 18, because here minus is there, plus into minus, minus 18, then 2 into 1, it is 2. So minus, already one minus is there, so minus into minus, it will become plus, so plus 2. So your answer is minus 16. So del 2, for that you need del 2 by del. So I2 equal to del 2 by del. Del 2 is minus 16 divided by del. Del is 20. So minus 16 divided by 20. So equal to minus 0.8. So I got I1 as 0.4, I2 as minus 0.8 using Cramer's rule. So all the methods, the answer is same. So I1 using Cramer's rule, I1 equal to 0.4, I2 equal to minus 0.8. They ask what current flowing through this 10 ohm resistor. So I 10 ohms, which is equal to 0.4 minus minus will become plus, plus 0.8. The current flowing through 10 ohm resistor is nothing but 1.2 amps. Suppose in your question, they are asking what is the current flowing through this 20 ohm resistor. So 20 ohm resistor is the independent branch, independent resistor. So 20 for I1. If you want to find out what current flowing through this 20 ohm resistor, current flowing through this 20 ohm means it's nothing but the loop current I1, which is equal to the current flowing through 20 ohm resistor. So your current flowing through 20 ohm resistor is, which is equal to I1. What is your I1 value? It is 0.4 amps. Suppose if they are asking the branch current flowing through this 60 ohm resistor means this is also a independent resistor. So I2 equal to 60 ohms, I60. So I60 ohms equal to nothing but I2. So the current flowing through this 60 ohm resistor equal to minus 0.8 amps. This is how we can find out the branch current or loop current using mesh. So this is two loop method. We can see one more problem also using mesh analysis. So we are going to solve using three loop. So determine the current through 5 ohm in the circuit shown in the figure. So this is 4 voltage source. This is 3 ohms. Here 3 ohms. This is also 3 ohms. This is 5 ohms. This resistor is 1 ohm. This is 1 ohm. This source is 8 voltage and then this source is 6 voltage. So they asked determine the current flowing through this 5 ohm resistor. So first step 1, you have to identify how many loops in the circuit. So if I am considering this point to this point, so this is also one loop. I am going to consider this as loop 1. So I am going to mention I1. Similarly, this point, this point, this point. It will start from here, its ends at here. So I am going to consider this loop as I2. Then this loop as I3. So totally 3 loops in the circuit. Step 1, you have to identify how many loops in the circuit. Next step, you have to label the current I1, I2, I3. I1, I2, I3. I already labeled I1, I2, I3. Step 2, you have to assign the current direction. So I am going to assign clockwise direction only. So I am going to assign clockwise direction I1. This is I2. This is I3. So I labeled, assign the direction, assign the current direction in clockwise and label the current. Label the current at each loop. I1, I2, I3. I1, I2, I3. Okay. Next, you can go with KVL or you can use by inspection method also. I am going to apply inspection method. So, using inspection method. So, once you form the matrix, you can form the equation. That equation which is equal to your KVL equation using inspection method. So, V equal to I into R. So, here 3 loops are there. If they mention 2 loops means only 2 cross 2 matrix. Here it has 3 loops. So, you have to mention R11, R12, R13. 3 cross 3 resistance. R11, R12, R13. R21, R22, R23. Similarly, R31, R32, R33. So, this diagonal always positive. Other diagonal, non-diagonal elements you just mention as negative. Then I1, I2, I3 equal to V1, V2, V3. We just form the matrix using inspection method. We are going to fill the parameters. So, R11, it means that the total resistance mentioned in the loop 1. Here 3 ohms, 3 ohms, 3 ohms. Total 9 ohms. So, total R11 is nothing but 9 ohms. So, in loop 1 alone you have to check 3, 3, 3. 3 plus 3 plus 3, 9 ohms. Then R12. 12 means the resistor which are both the loop current. So, this is I1, this is I2. So, if you are considering this I1 and I2, this 3 ohm resistor which are with both the loop I1 and I2. So, you have to mention as per your formula, this is minus 3 ohms. Similarly, R13, this is loop 1, this is loop 3. Here it mentioned as 3 ohms. So here you have to write minus 3. Then R21. 21 means the resistance which are with second loop and first loop. So here it also minus 3. 22. 22 means the total resistance present in loop 2 alone. So 1 here 1 ohm is there, 3 ohm is there, 5 ohm is there. So 5 plus 3 8, 8 plus 1 9. So 9 ohms. Then R23. 23 means the resistance which share both the loops, loop 2 and loop 3. It is nothing but 5 ohms. So you have to mention minus 5. Then R31. 31 means the resistance which shared with third loop and first loop. So here 3 ohms, right? This is loop 1, this is loop 3. So 3 ohms. So you have to mention minus 3 ohms. Then R32. 32 means the resistance which shared with loop 3 and 2. It's nothing but 5 ohms. So you have to mention 5 ohms here. Then 33. The total resistance present in loop 3 alone. So 5 plus 3 plus ohm, it become 9 ohms, right? So 9 ohms. So it will also become minus. So once again you have to check whether the diagonal elements are positive. The non-diagonal element should be negative. If you are using inspection method, you have to check other non-diagonal elements should be negative. The diagonal element should be positive. Okay. Next, this I1, I2, I3. We don't know. We need to find out. And then this is V1, V2, V3, right? V1 means loop 1, the total voltage at loop 1. Here 4 voltage is there. Once you check with the voltage, you have to check with the assigned direction also. So here the direction which goes like this, right? So this is my assigned direction clockwise. Minus plus. So it's the arrow head ends at plus. So you have to write positive 4 voltage. 4 volt, right? Then V2. V2 means the source voltage present at loop 2. Here you have to check with this assigned direction. The assigned direction go with minus to positive only here also. So if you are taking this direction here means it will go with the arrow ends at positive only. So you have to write plus 8 voltage. Okay. Next, the source voltage present at loop 3. So loop 3, the source voltage is 6 voltage. So the arrow shows that it goes with positive to negative. So it's nothing but minus 6 voltage. So each and every time the voltage source you have to check with the assigned direction. The arrow ends at positive means you have to take positive voltage. The arrow ends at negative direction. Assigned direction ends with negative means you have to consider negative voltage. So this is how we just form the matrix using inspection method. Now I am going to form the equation. So 9 I1 row into column. So 9 I1 minus 3 I2 minus 3 I3 equal to 4. This is equation 1. Similarly here minus 3 I2 plus 9 I2 minus 5 I3 equal to 8. This is my second equation. Then minus 3, this is I1, minus 3 I1 minus 5 I2, then minus minus 3 I1 minus 5 I2 plus 9 I3 equal to minus 6. Now you got the three equation, system of equation. Using your calci, you can find out the what is I1, what is I2, what is I3. Okay. So using my calci, I am going to check what is I1, I2 and I3. For that, you have to go mode clear, you have to press mode clear. If you are pressing 3 times means it will show equation matrix VCT. You are going to solve by equation only. So you have to press 1 for equation. It will ask how many unknowns, 2 or 3. Here I1, I2, I3. 3 unknowns are there. So you have to press 3. It will ask what is A1, B1, C1, D1. D1 is nothing but equal to value. Here 4 is D1. Similarly, it will ask A2, B2, C2, D2. A3, B3, C3, D3. You have to press all the values, coefficients of these values. So A1 is 9. If you are pressing equal to means it will ask B1 value. So B1 is minus 3 equal to C1 is minus 3 equal D1 is 4. Then A2 minus 3 equal to B2 is 9, C2 is minus 5, D2 is 8. Then A3 minus 3 minus 5, C3 9 equal to D3 minus 6. So your I1 is 1.2, I2 is 1.6, I3 0.6. So 1.2, Y1 1.6, I3 0.6. So I found what is my loop currents, I1, I2, I3. But the question is determine the current flowing through 5 ohms resistor in the circuit. The 5 ohm resistor present here, right? So you can find out I5 ohms. So you know what is your loop current I2, your loop current I3. So the current flowing through 5 ohm resistor is, you can write I2 minus I3 or you can write I3 minus I2 also. Only the sign will differ, the magnitudes are same. So I2 is 1.6, I3 is 0.6. So minus 0.6. So you'll be getting 1 amps. 1.6 minus 0.6. So I5 ohms equal to 1 amps. So today's class we solved 2 problems using mesh analysis. I hope all will understand this method. So you can go with Cramer's rules also, or you can go with the KVL. You can form the KVL equation also, the same equation you will be getting. Okay, thank you.